This conference will now be recorded.
Okay, good morning, friends. So, in this particular session, we are going to talk about Spark partitioning. What is Spark partitioning? So, what are the partitioning strategies that we need to use to optimize our code execution? Then, what are the different types of transformation that we have to adjust the number of transformation? Okay, adjust meaning, so sometimes what happens, the number of partitions that are created in your code will be very low. You need to increase it. Sometimes there are a lot of partitions got created. You need to decrease the partitions. So there are two transformations that you can use to decrease. One of the transformation that you can able to use for increasing. So those two transformations are basically repartition and coalesce. We will understand when to use repartition, when to use coalesce. Okay. Next, how repartition works internally. We will look at how repartition works internally. We will see. Then we will see how Coalesce works internally. So as I mentioned, these two are a transformation. How repartition works, how Coalesce will work, when to go for repartition, when to go for Coalesce. So those are all things we will see in the difference between repartition and Coalesce. Finally, we will see Spark configuration. Spark configuration means the default behaviors, whatever is there, the number of partitions that are creating, how we can able to change by default. Whenever you read a file, by default it is creating 2 partitions. I want to make it a 8 partition based on the file size. How you can able to configure those things. Example, I have 100 GB file, so I want to make sure each partition size is 250 MB. Okay, so I said 100 GB, right? Sorry, when the 100 GB file I am trying to read, so if I want to create each file with 1 GB, each file with 1 GB, you need to put it in a Spark configuration, saying that so each partition size must be a 1 GB. Now 100 GB file I have, so each partition I am saying 1 GB file. When I say each partition is 1 GB, how many partitions it will create?
100.
100, right? Very simple calculation, 100. So whatever we discussed as of now, everything we will see practicals with respect to the RDDs, how it will work, with respect to the data frames, how it will work, how to make Spark configuration setting up, how we can able to set the Spark configuration. Everything I'll try to show practically. Before that, 5-10 minutes I'll just explain theoretically, because theoretical knowledge is also important. So once you understand theory, then we will go into the lab. So we will have more of a lab today. So there are a lot of queries we need to execute and we need to see practically each transformation, how it will work. Okay. So yeah. So first, partitioning. What is meant by partitioning? What is meant by partitioning? What is meant by partitioning?
Dividing work into smaller chunks.
Very good. So if you have a cake, okay, so if you cut the cake into 4 pieces, if you cut the cake into 4 pieces, what happens? So if you cut the cake into 4 pieces, basically if you cut 2 times, you will get a 4 pieces, isn't it? So each piece is nothing but you can call it as a partition. Okay, each piece is nothing but you can call it as a partition. So total cake you cut it into 2 times horizontally. So like you can say north to south and east to west, something like that. If you cut it, you will get a 4 pieces. Each piece you can call it as a partitioning. Okay, now in this cake, how many partitions we have? 4 partitions. If we have a more people, so I need to distribute the cake among multiple people, not only 4. There are multiple people. What you will do in that situation? You will cut it into small pieces. Then the number of pieces are going to be increased or not? Yes. Then the number of pieces are going to increase or not? Yes. Similarly, if our cluster size is big, then we can basically create a more partitions based on the cluster size. If the cluster size is big, If more computers are there, more cores are there, then you can create a more partitions, meaning more chunks you can create. What is the advantage of creating this partitioning? What is the advantage of creating this partitioning?
Works all
Parallelism.
Parallelism.
Parallel.
Parallelism. Okay. So let's say if I have 100 chocolates, okay, if I have 100 chocolates, if I give one person to eat all the 100 chocolates, if this person is taking a 1 minute to eat a one chocolate, now how much time this person take to eat 100 chocolates?
minutes.
100 minutes. The reason is only one person is there. He need to eat 100 chocolate. Each chocolate is taking to eat 1 minute. He is taking a 1 minute to eat one chocolate. Now as we have 100 chocolates, he will take 100 minutes to eat. Now the question is, if I have two people, so these two people are eating parallelly. So how much time will take to finish all the 100 chocolates? 50 minutes.
50 minutes.
If I place four people, then
25.
25. If I place 10 people, then 10 minutes. Very good. That's all. Simple calculation, right? If I have a 10 people who are eating the 100 chocolates, each person will get a 10 chocolates. So all these people are eating parallelly. Within 10 minutes, I can able to eat all the 100 chocolates. Meaning, whatever work which we need to finish, if we have a one person, it is taking 100 minutes. If we place a 10 people, it is taking only 10 minutes. How we have achieved, how we are able to eat all the 10 chocolates in 10 minutes, sorry, 100 chocolates in 10 minutes is using the parallelism. Using the parallelism. Parallelly, 10 people are eating the chocolates. Parallelly, 10 people are eating the chocolates. Similarly, here, there is a worker nodes, right? There are computers. So each computer basically will have executor, as we discussed in the Spark architecture. Then each executor will get the cores. So based on the number of cores, we can basically give 1 to 4 partition per core. Per one core, we can give minimum of one partition, maximum of 4 partition. This is recommended. You can give more also, but that is not recommended in terms of the performance. Okay, the reason is per core, if you are giving more than 4 partition, meaning each partition, one by one partition, it has to take, it has to schedule, then it will be deserialized and compute. The calculation will happen. Again, it will be serialized and it will generate the output. There is a lot of process. So if you have more partitions, then all these partitions should go through this process. What happens is basically it takes more time. Okay, it basically takes a more time. Now you understood what is partitioning, the usage of the partitioning. Partitioning is nothing but if you have 100 records, if you divide 100 records into 4 partitions, each partition will get 25, 25, 25, 25. Now I have a 4 people who are going to execute these 25, 25, 25, 25. So I have 4 people. So for each person, I'll give a 25 records for processing. So all the 4 partitions will process parallelly so that the overall execution time will be reduced. Understood? What is partitioning? We understood. The use of the partitioning also we understood. Now partitioning is nothing but a dividing data structure, your whatever data 100 records or whatever into parts. You are dividing that 100 records into parts. In a distributed system like Apache Spark, distributed system, what is meant by distributed system? As we discussed, it's not a single computer. You have multiple computers. You need to distribute your work. You need to distribute your chocolates. You need to distribute your records. It can be defined as a division of a data set stored as a multiple parts across the cluster. So we are basically dividing, we are applying the division on the data, whatever data you have. If you have 100 records, you are dividing 100 records into 4 parts. So each part is nothing but a partition. So all these 4 partitions will be executed in the cluster. Spark uses 3 main data structures. One is, RDDs. Second one is DataFrames. Third one is dataset. As you know, RDD and DataFrames, we will see datasets are not supported in Python. That's why we will not talk about the dataset. We will see why it is not supported, all those things later. But RDD and data frames, we will see with respect to RDD how it will work, with respect to data frames how this will work. Both are same, but small functions, everything will be little bit different. We will see practically. No, sorry. Partitioning strategy. If you see the partitioning strategy, first partitioning strategy is bad partitioning can lead to a bad performance. Bad partitioning can lead to a bad performance. Okay, simple. You have 100 chocolates. Okay, if you maintain 100 people, what will happen? I have 100 chocolates. If I keep 100 people, then what happens? Cost will increase. Cost will increase. Yes, within a 1 minute that will be executed. First thing is cost will increase. Second thing is this is not the way to basically execute. Okay, what you need to do, if you have so many partition, let's imagine there are 3 worker nodes. Okay, 3 worker nodes. Now when you have a 3 worker nodes, each worker node can execute 4 partitions. Each worker node can execute a 4 partitions. 4 into 3 how much? 4 into 3 how much? 12. 4 into 3 how much? 12. Now at a time we can able to execute the 12 partitions. If you have created you have just a 100 records. If you create 100 partitions, what will happen? I have let's imagine I have 3 computers. Each computer can execute a 4 partitions, and 4 into 3 is 12 partition I can able to execute at a time. Let's imagine I have a 120 records and I created a 120 partitions. I created a 120 partitions. Then what happens? So as the partition size is very small, what happens is, so first 12 partitions will be submitted on the worker nodes. So for all these 12 partitions, the task scheduling will happen. Then the deserialization, compute, so serialization, then generating results. So that flow we have seen, right? So that particular flow will be executed in Spark UI. I have shown you event logs. So there what happens is 12 partitions are basically executed one time. Next time, once these 12 are completed, next 12 will come. Next 12 will come. How many times we need to submit these partitions? If you have 3 computers, each computer can execute 4, meaning total 12. I have 120 partitions. Okay, so how many times I need to submit?
10 times.
10 times. Even though I am not submitting, basically one after the another cluster will take and execute, but 10 times it has to schedule, 10 times it has to deserialize, then it has to compute, serialize, generating the output. So it basically takes a lot of time. Unnecessarily we are spending more time for this scheduling. 10 times it has to schedule. Why this happened? Because you have created very small partitions. Too many small partitions you have created. This is the problem. So other way, what happens is you created very few partitions. Very few partition means I have 120 records. You created just 10 partition. So here I have 3 computers. Each computer can able to execute 4 partitions. Total I can able to execute at a time 12 partitions. But how many partitions you created? 10. So meaning 10 partitions are executing, two more partitions cluster can able to execute at a time, but you have not created optimized number of partitions. Instead you created just 10 partitions. Maybe you have created less than 10. So what happens in all these cases is you are not using the cluster in optimized way. That is the first problem. Second problem is, if the partitions are, if you have created less partition, the partition size will be more. When the partition size will be more, the memory, right? So the CPU issues will come up. Okay, because very big partition it has to execute, right? So maybe memory and the CPU, those issues we may get it. We have seen in Spark architecture. So each the task, how much memory, how many cores it can get it, right? So this is the main problem. That's why bad partitioning can lead to a bad performance at any time. Make sure you should not have too many partitions or too few partitions, meaning you should not have a too many partitions or you should not have very few partitions. You need to maintain the optimized number of partitions. Clear? We already discussed what is the optimized number of partitions. As I said, per core, make sure one partition to 4 partitions you are submitting. So earlier case, what happened? Each core is getting how many partitions? 10 partitions. When we have taken a first example, 120 partitions I have. So each computer can execute a 444 partitions, meaning total 12. Meaning on each core, 10 times I'm submitting the partition. Okay, meaning per core I am assigning a 10 partitions. That is not recommended. Maximum recommended is 4, minimum is 1. Clear? Any doubt here? Next, too many partitions regarding your cluster size and you won't use efficiently your cluster. Too many partitions means, as I mentioned, you are not basically using your cluster efficiently. The reason is simply you are scheduling the task. Again, it will be deserialized, computed. So compute is basically, that is what is going to happen on the worker nodes. So remaining scheduling, everything will happen on the driver node. Driver node will take care of the job, task scheduling, everything. Okay, so basically what is happening is only compute time will be run on the worker nodes, remaining time will be on the driver node. So unnecessarily you are scheduling multiple times the same job, basically very like you have created multiple partitions, right? As you have created multiple partitions, multiple times you need to schedule the job. Next, not enough partitions regarding your cluster size and you will have to deal with the memory and CPU issues. If you don't have enough partitions, 12 partitions I can able to execute at a time, but if you have 6 partitions, then what is going to happen? 6 are very big. Maybe the one partition we need to execute, right, on a task, but that task may not have a sufficient memory and cores. Okay, cores will be there, but sufficient memory may not be there, isn't it? So that's why you should not create a very few partitions or you should not create too many partitions. Two things. Next important thing is you have 100 records. You are dividing into 4. When you are dividing the 100 records into 4, you should not divide like, okay, first part is 60, for the second person is 20, third person 10, fourth person 10. What kind of distribution it is? Is it a equally distributed or not equally distributed?
Uneven distribution.
Uneven distribution. Very good. So the name is called a uneven distribution. This is nothing but a skewness issue. In Spark we will call it as a skewed data or skewness issue. So this is the problem. Okay, this problem mainly comes when you use the Coalesce. When you use the Coalesce function, you will have this kind of problem. We will see practically. I'll show you each and everything. Next, partitions are unbalanced. Unbalanced means it's basically not evenly distributed. It's unbalanced in terms of data volume. Yes, data volume is first partition is having 70 records or 60 records, second partition is having 20 records, third and fourth is having 10 records. Some tasks will run longer compared to others and will slow down the job. Basically what happens, the first partition is having how many records? 60 records. As the first partition is having many records, it takes basically long time to run. So the overall job time is basically going to increase as the first partition is still running. Why it is running? Because it has a lot of data to execute, but other tasks are completed because other tasks are having very few records. Okay, next, how the data will be partitioned. How the data will be partitioned is based on the two partition types. One is hash partition, second one is range partition. So hash partition means, you know, right, based on the hash value. Let's say if you take a location, so all the India location will come into one partition, or US will come into another partition, all UK will come into one partition. That is the hash partition. So when it comes to the range partition means, okay, some range it will take, okay, from 1 to 50 is one partition, 50 to 100 is another partition, 100 to 150 is another partition. That is the range partition. So hash partition, we will have a problem when you don't have a proper column for partitioning. If you have India, like if you take a population, based on population, if you divide a partition, so what happens? India is having 130 crores of people. So this partition is going to be very big. If you take US, it's just 30 crores or something, right? So then what happens? It's a basically what happens is the partition size will be very small, but India partition is going to be very big. If you take a partition key is based on a country, understood? So that's why you have to use hash partition only if you have a proper column. Okay, so we will see all these things. These are the some of the partitioning strategies. What are the partitioning strategies is, make sure you need to have a optimized number of partition. You should not have too many partitions, or you should not have very few partitions. Next thing is, make sure data is evenly distributed. If your data is unevenly distributed between the partition, there is a problem. Clear? So if I give you one example, let's imagine you have a cluster with let's imagine maybe 1000 GB memory, and you have 256 cores. Okay, but you just created a 10 partitions. You just created a 10 partitions. 10 partitions will run with the 10 cores, and maybe it is using the 100 GB. Okay, remaining 900 GB of memory is idle, and 246 of the cores are going to be idle. You are basically wasting, as we have created very few partitions. That's why you need to optimize the partitions. Now, both repartition and Coalesce are the transformations provided by Apache Spark for changing the underlying partitions of the RDD or data frame. If you want to change the partition count from RDD or data frame, you must use repartition or Coalesce. Repartition can be used to increase or decrease the number of partitions on the RDD and data frame, whereas Coalesce can only be used to decrease the number of partitions on the RDD or data frame. Everybody understood? Repartition can be used for increasing or decreasing, meaning let's say I have 100 records. It by default it is created 4 partition. 4 means each is 25, 25, 25. Now if I use a repartition, I can make these 4 partitions 25, 25, 25 into 10. 10 meaning each partition may get 10, 10, 10, 10 records. 10 partition I can create. Similarly, I can make it as a 2 partition. If I make it as a 2 partition, each partition will get how many records? 50, 50. Got it? Now, what about Coalesce? Coalesce only for decreasing the number of partition. You cannot use for increasing. If you try to increase using the Coalesce, the transformation will be ineffective, meaning that will not be applied. Okay. Now, Coalesce basically, if I use Coalesce and try to decrease to 2, what happens? Again, same problem. Like problem meaning, so 25, 25, 25, 25. There are 4 partition. Each partition is having 25. Now, what happens is when you decrease to 2, each partition will get a 50, 50. But there is a small problem in the Coalesce. It will get a uneven distribution because the shuffling will be very less. Let me show you practically internally how it will look like. Okay. How repartition work is, let's say I have 3 computers. Okay, in each computer I have a 2 partition. The partition is having the data like 10, 20. Second partition is having data 30, 40. Third, fourth, like there are 2 more partition in the system to 50, 60, 68, 70. Similarly, in the third computer I have 80, 90, 98, 19. Okay, so these 3 computers I have. Now I have used df.repartition of 3 or rdd.repartition of 3. If I made it as a 3 partition, then what happens is first it will combine all this data. Okay, it will combine all this data. Then what happens? This 3 partition I need to create, right? So now what happens is some records from the first computer will go to this computer, and some records from the second computer will go to first computer. Some records from third computer will go to the first computer. So now one partition will be created in a computer 1 with a 10, 20, 50, 80. 50, 80 are coming from another system. Similarly, so this system also may receive a record from the first node, second node, and third node. So here it may form 30, 60, 68, 90. So if you see, 30 is coming from the first system, 60, 68 is coming from the second system, same system basically, 90 is coming from the third system. When it comes to the third system again, so from all these three computers, so data will come and join here. So basically now source side you have 6 partition, sink side how many partition it became now? Sink side how many partition it became now? Only 3. Each computer is having 1 1 1. Okay, got it. This is the basically what happened. Full shuffling. Full shuffling means from each system data is moving to all the systems, all other systems. Okay, so data will be basically what happens internally. If we discuss more on this, it combines all these 3 systems data, then it will move some data to here, some data to here, some data to here. Basically it will combine all this data, then it will move some data to here, some data to here, some data to here. So that is what I was trying to replicate here. Clear? Next, this is the repartition. Repartition, everybody understood? Now Coalesce, how it will work is same. See, basically repartition you can use for decreasing or increasing. Increasing, we have only repartition. What happens? It will simply increase it. Maybe if we have 10, 20, 30, 40, if you made it as a 9 partitions, then maybe from like here itself 3 partitions will be created. So each partition will get some records from here, some records from here, some records from here. So maybe that is also possible, increasing. Now, basically here I just explained with the decreasing the number of partitions, okay, using the repartition. Same I can also achieve it using the Coalesce. I can also decrease the number of partitions using Coalesce. How it will work? Now you see 3 systems again, 10, 20, 30, 40, something like this I have. Now this time I applied a df.coalesce of 3. Now what happens is, now you see, basically from this within this system itself it will combine 10, 20, 30, 40. Within this system itself it will combine 50, 60, 68, 70. Within this computer itself it will combine 80, 90, 98, 19. So here what happens? Avoid shuffle as much as possible. It will, what it is doing, avoid shuffle as much as possible. If I say 2 partitions, then it must move this one of the system records into the another systems. Okay, but see, Coalesce, you cannot say that it will not do the shuffling. It means that it will always try to avoid as much as it can do. But there will be shuffling in the Coalesce also. But what happens is it will try to reduce the shuffling of the data. Okay, clear? All of you clear? So now what happens is, as it is reducing the shuffling, let's say here you have 100 records, here you have 30 records, here you have 30 records. Then what happens is, so here you will see 100 records, here you will see 30 records, here you will see 30 records, meaning there is uneven distribution. But here when you go to the Coalesce repartition, right, earlier one, what happened? So here even though you have, so let's imagine, so in this case what happens, even though you have 100 records here, 30 30 here, when you decrease, what happens is this 100 records, some will move to here, some will come to here, some will move here, 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 here. Then what happens, the possibility of even distribution is more in the repartition. The possibility of uneven distribution is more in the Coalesce. Uneven distribution. Got it? Everybody understood? Any doubts? Fine, let's move on. Difference between repartition and Coalesce. Okay, see, first, repartition can be used for increasing or decreasing number of partition, whereas Coalesce is used to decrease number of partitions. This is a very important interview question as well. Second thing is, does not worry about amount of shuffle, how much data is shuffling. If you don't want to worry, then you need to go for repartition. But there is lot of data. If this much data is shuffled, there is a problem, then you can try to use a Coalesce. What Coalesce will do, it will try to avoid the shuffles, but it also do shuffling. So but whatever is extra partitions are there, only those partitions it will adjust. Repartition is basically slower than Coalesce. Remember, wherever there is a shuffling, there is a performance issue. That's why there is a shuffling in the repartition. That's why repartition is slower than Coalesce. So better performance than repartition because there is less shuffling of the data, less movement of the data between the systems. Fourth one is tries to create a partitions of similar size. the even distribution is possible in the repartition, whereas in the Coalesce it is uneven distribution is like more likely uneven distribution will happen. I'll show you practically. Okay, everything I have included in the notebook, everything we will see. Okay, so before I move on to the practical lab, any questions? Anybody have any questions?
Maria, I have one question. So whenever we are facing this performance issue, at that time we have to implement this repartition and coalesce.
Yeah, repartition and Coalesce, you need to adjust your number of partition. So as we discussed, if you remember in Spark cluster, Spark architecture, when we discussed right how many partition we can submit on the cluster. So based on that, if you calculate, what happens is you know how many partitions your cluster can able to execute. So make sure those many number of partitions we have are multiple of that. Example, your cluster can able to execute 64 partitions at a time. Try to create 64 or 128 or multiple of 64. Basically you need to do. Got it? Why multiple of
Yes,
64? Very simple. If you have a two partition, I can able to execute in my cluster. If I have then what happens is, if I have a two partition, no problem, everybody like these two systems will execute one partition, everything will be done at once. Now if I have three, then what happens? First time first person, second person will execute, but the second time what happens is only one partition is left. One of these person only can able to execute, other person should sit idle, meaning you're not using your cluster properly. Like that, if you see this example I have given with only 2 years for your for easy understanding, but generally if you understand with a more partitions, what happens, you need to create a multiples of the original partition count. Okay, let me just tell you. See, one surprising question I'm seeing here. That's okay. See what I'm saying? See, one thing is I just completed few sessions. You people are not able to go through those sessions. I'm giving some leaves also. I'm not taking classes continuously. You're seeing, but same problem I'm seeing here. You people are not going through whatever we covered. So I already explained this part also. If you have a two partitions, then what happens? This particular system will execute these two partition, done. Our job is done. If you have a three, then what happens? First time one will complete. Next, this will take the third partition. What about this? So at this particular time, this system you are not using properly. You are not using. This is idle. You are making it idle. So this should not happen. You need to use your cluster properly. So if you have a two cores basically in your cluster, make sure you have a two partition or four partition or six or eight, max eight. That is the recommended. Okay. So now what happens if you have a four, first two will be executed, after those two, next two will be executed, after these two, next two will be executed, like that in the sequence, two will be executed on this particular CPU. Clear? All of you clear?
yes, ma'am.
Yeah. Now, so when to use repartition? When to use repartition is if you want to decrease or increase the number of partition, you need to use a repartition. Coalesce you need to use only for decreasing the repartition. Now the question will come. So for increasing, there is no choice, only repartition. Okay, I'll go and use the repartition. For decreasing, when I need to use repartition, when I need to use a Coalesce. Okay, so Coalesce is the preferred one for decreasing the number of partition because it will do the less shuffling. Okay, but you also need to make sure your data is evenly distributing or not. If the data is not evenly distributing, there is a problem. Okay, there is a problem. The problem is, as I mentioned, if I have 100 records, if I'm dividing into four, first person got 60, second person is getting 20, third person is getting 10, fourth person is getting 10. This is uneven distribution. If this is the probability of getting uneven distribution in Coalesce is more. Okay, that's why you need to check whether that kind of things are happening. Okay, if that kind of things are happening, you have to go and use the repartition. Okay, so all those things I'll show you practically. Let's move on to the practical things, so that we already spent on theory itself, we spent a lot of time. So let me just execute. Cloud Pandit 27, I think. It took a lot of time to explain theory only, but practicals is very easily you can able to understand. Let me create the cluster here. Create cluster. In which notebook I made the changes? Just give me 1 minute. Give me a minute because I did not remember in which account I have done this. Give me 1 minute. Okay, fine. So here let me quickly create the cluster. Okay, cluster is also ready. Click on resend, go to partition versus Coalesce. Repartition versus Coalesce. Okay, repartition versus Coalesce. Now you see, so first thing is, what are the minimum number of partitions that will create here? So what is the configuration set? Let me just clear the results here. So now you can see this parameter basically tells you what are the minimum number of partitions this particular notebook will create. Okay, you can see using this particular configuration, you can see what is the default number of partitions it will create. Minimum number of partitions is 2, it will create. So what is the maximum number of partitions it will create? If you see this, it will tell you the maximum number of partitions it is going to create is 8. The minimum number of partitions it is going to create is 2. It's by default. By default, if you have a small file, it will create 2 partitions. If you have a very big file, it will create 8 partitions. But you can change the behavior. You can create a 60 partition. You can create 200 partitions. How you can able to do those things, I'll tell you. So first look at this. There is a stores4.csv file I just uploaded. If you want to see the size of this particular file, let me show you. As you know, dbutils commands, as we discussed, dbutils.fh.ls. ls basically used for listing the files. Okay, now I want to list down the files that I have under the store4. Sorry, under tables. If you see store4.csv, it's just a 236 bytes. It's very small file. Okay, so this particular small file, when I'm reading, okay, how to read and create the RDD. SC is nothing but, if you are very quick,
Spark
I can
context.
able to
Spark context.
So using that Spark context, I'm reading this particular file, which file store4.csv. It basically creates the RDD. So now if I want to know the number of partitions that I have in this particular RDD, r1.getNum partition. If you don't forget this, you just click dot and say tab. It basically load everything. As I am telling you, just say get. Okay, get and again click the tab. So it will tell you get num partition. You select and execute this. So this is the intelligence you can able to use to get the function name something. If you don't know whether it is a small character or upper lower case, which case I need to use, what is the function name and all, you can search it. Okay, so what is the minimum number of partition it is created when I read a small file? 2. Everybody's clear on this? Now I want to know what records are moved to the partition 1, what records are moved to the partition 2. Let's execute this. R1 dot in this R1 glom is a function which basically give you the records that are there in a partition. See, there are 2 partitions, right? See, this is the first partition, this is the second partition. So in first partition, how many records are there? Basically 3. In second partition, how many records are there? 4 partitions. 4 records. First partition is having 3 records. Second partition is having 4 records. Total 7 records. Clear? How to know the count of records in a RDD? R1 dot count. Total 7. Clear? All of you clear? On first partition, how many? 3. On second partition, how many? Second partition, how many? 4. So you are basically calculating like this because it's a very simple number. But now I'm going to take some 10 million records. You see here, I'm basically taking some 10 million records. Okay, so spark dot range, basically let me show you all these things because I'm not sure whether how much you remember. I don't know. That's why I'll take a simple example of 10 if I give and show. Just showing you because see, 10 means, you know, range of 10 means 0 to 9. Whoever attended my Databricks, you know, because we discussed Python range data type we discussed, right? Range basically you can define in a 3 different ways. You can put the starting value, ending value, and a step value. 0 to 9, 10 if you give. If I give 20, it will give 0 to 19. It will give 0 to 19. You can see 0 to 19 it is giving. Got it? If I give 15, it will, if I give 15, how many records it will give? 0 to 14. See, 0 to 14. Got it? So similarly, spark dot range of how many records I'm generating, basically if you say 10, I think only 10 lakhs, only 1 million records I'm generating. So as I mentioned, the minimum number of partitions are 2. That's why when we have read this small file, it created 2 partitions, but now it's a 10 lakhs, 1 million records I'm basically passing to this particular parallelize function. This is another way to create the RD. This also we discussed. R2 dot get num partition. This time I'm asking how many partitions we have created. How many? 8 partitions. Clear? Now it is very difficult for you to understand which records are moved to the partition 1, which records are moved to the partition 2, and so on, right? Because example, if I say like this, it's very difficult for me to difficult for me to get the number of partitions that I have in each partition. The number of records available in each partition, I cannot go and check it. So here simply 7 records I just verified, but it's a 10 lakhs. Okay, 10 lakhs meaning 1 million records. I cannot simply go and check like this. Okay, 1, 2, 3. If I calculate like this, 1 year it will take. It's difficult. Okay, but what is the way? There is a way. I'll tell you. So come here. So same R2. R2 is nothing but here you see, you read, right? You created this R2. I'm taking that RDD. Okay. So from this RDD, there is a map partition with index. There is a transformation. What this R2 RDD will give is 2 things it will give. Partition index. First partition index is called a 0th index. Second partition index will be a 1. Third partition will be a 2, and so on. Now this will give you 2 things, index and partition. So entire partition data, then which partition is it, a 0th partition, first partition, these 2 things it will give. So what I'm saying is R to RDD map partition with index. I'm passing the index and partition both to this function. What this function is doing, it is taking this partition, all the values that are there under partition it is taking, and it is keep on iterating to count it, to get the count. So finally it is returning okay, this is the 0th index, the total count is this much, total count is this much. Next, so again it will pass the second so like a second partition, and index is 1, entire second partition data it will pass. Again we will count how many records are there in this particular partition using the part iterating. I am iterating through one by one record and increasing count. The total count I am returning for this particular index, meaning that particular partition. Like that, I'll collect for all partition the count, the number of records, but I'll not checking the actual data that is there. Instead, I'm just checking. You see here, 0th partition, the records are 1,24,928. Similar, same for all the partition, almost same, except this. This is little bit, it's not a big deal, right? It's not an uneven distribution. You cannot say it's an uneven distribution because it almost 1,000 or like more or less we can accept it. It's not a very big change. It's an acceptable number. Okay, you cannot expect everything evenly, very even. Okay, clear? Everybody is clear on this? How I calculated the number of records from each partition in RDD? Everybody's clear here? Okay, now why I'm again and again I'm asking, because this function is very important. Any doubts in this function, let me know, because this is the function which we are going to use almost for next 10 more cells. Any doubts in this function?
Malaya, these function we are creating, right? DF means that is we are creating, right?
Yeah, it's a Python function that is created by we have created. You can give any name for this function. Okay, I can give a, like whatever name you have given, same name you need to give, so that with this name, whatever function is there, that function will be called. As I mentioned, this map partition with index means this RDD will pass two things, index and a partition. So basically, how you will know it will pass to, you need to read the documentation and you will come to know. Okay, so I got it, I got some information there, it will pass index and the partition. So these names can be anything. So I just used index and part is nothing but partitioning. So the relevant names I just used. So similarly you can use. Okay, clear?
Clear.
Now come down. So now what I am doing, R2 is basically earlier how many records are, how many partitions are there?
8.
R2 is having how many
8
partitions,
partitions.
earlier? Huh? 8.
8.
Okay, 8. So now I am making it as a repartition of 16, meaning I am making a 16 partitions. Now what happens, these 8 partitions data will be shuffled between the 16 partitions. Okay, now R3 is the resultant. Now I want to check how many partitions I have in R3. Check it. How many are there? It is saying 16. Clear? Now you take a R3. Now you take a R3 and call same function. You take R3 and call same function and ask the number of records in each partition out of 16. Got it? Okay, now you see 0th is 62,498, 62,500, 62,000, 62,000, 62,000. Okay, so everything is basically a 62,000 only. You can see 62,000, 62,000. So we don't see much difference. Basically, it's a almost even distribution we are able to see here when we increase the number of partition using the repartition. Got it? Clear? Till here clear? These practicals are very important. Next, come down. So sc.parallelize of so I am here basically taking same 1 million records R4. This time, you know, right, the number of partitions, how many by default it will take? 8. You see here, by default it is taking 8. Why it is taking minimum is 2, maximum is 8? Because as I mentioned, if you see the number of cores in this cluster is 2. 2 means the minimum 1 is the preferred, maximum 4 is the preferred, but more than 4 is not recommended. That's why minimum is 1 per core, 1 partition per core. 4 partitions per core is the maximum limit. Minimum limit is 1 partition for 1 core. That's why minimum core is 2, minimum partitions are 2, maximum partitions are 8. Now, so if you see here, like 10 lakhs, 1 million records when I have taken. So when I say get num partition, it is giving 8. Now I can basically do a repartition of 6. Repartition of 6 means what I am doing? I am decreasing the number of partitions. Okay, I am decreasing the number of partitions. Okay, so I just decrease the number of partition. I want to ask the number of partitions that I have under this now. R5 dot get num partitions I am asking. Okay, it is saying 6 partitions. Now I want to take R5 and I want to get the count from each partition. Let's see now. Count from each partition. How many records are there under each partition? I want to check it now. See now, 166, 166, 166, 166, 166, and 166. Got it? Fine. Now, when I read this R6 again, I am reading this 1 million records, and I am trying to get a num partitions. I am trying to get a num partition. So, did you remember when 8 partitions was created? All these 8 partitions were there in a even distribution fashion or uneven distribution distributed fashion?
Even distribution.
Even distribution we have seen. Now what I'm trying to do, I'm trying to reduce this partitions to 6 using the Coalesce this time. Okay. Basically you can execute both at once. You can also reduce and you can get the num partitions. So basically it will give you the number of partitions are 6. Yes. This time we use the Coalesce to reduce the number of partition, but this time we are using the Coalesce. Now using R7, I'm trying to get the number of records in each partition. Now let's see. So you see 124, 124, 255. Is it an uneven distribution or not? Is it a uneven distribution or not? Yes. Same thing you see here. 166, 166, something it is divided, right? See here. 166, 166 is divided, but when it comes to the Coalesce, it is not moved the sum of the partitions. So out of 8, some partitions it kept as it is. You see, it is not moved. But remaining 2 partitions, some partitions extra, it just added. That's why here is 250. Here is also almost 249, means almost 250. Meaning two partitions it combined and it created the single partition, but basically it is not moved all the records. That's why here we are able to observe uneven distribution. All of you clear? Everybody observed here uneven distribution. Why uneven distribution is happened? Because data is not moving. Data is not moving. That's why the uneven distribution happened here. Clear? 5-10 more minutes. What?
Will also not happen, right?
I did not get you.
Shuffled is not happening.
Shuffling
Right?
shuffling is not happen. That's the problem. Okay, less shuffling will happen. Less shuffling means, so example, this partition will combine and it creates a 255, like 250,000 records, 249,000 records. 2 partition combined, but 2 combined means 4 will create a 2 partition. Remaining 4 are as it is here. You can see. Okay, got it. Next, I can move on to the data frames, or you need some time. Just let me know. Everybody is clear on this? Next. So same thing, we will look at data frames. Okay. So basically, first thing is how to get the num partitions on the data frame is there are 2 ways. There are 2 ways in which you can get the number of partitions that are created in a data frame. So first way is, this is the data frame I created. Okay. You want to see what data we have under this data frame. Top few records I'll just display. Okay. df.show by default it will show top 20 rows. You can see here 0 some current date I just generated. Okay, this is the data frame. Now in this data frame, if you want to know the number of partition, you can see df.rdd.get num partitions. Execute this. How many partitions it created? How many partitions it created? 8 partitions. Next, come here, spark dot. This is the one of the way to get the num partition. Basically what you are doing here is data frame you are converting into RDD. From the RDD again you are getting the num partition, whatever you applied on the above cells. Okay, now come down. So spark the range with column, same thing. So here what I'm doing is to get the count, basically to get the number of partitions. What I'm doing is with the column, there is a function called Spark Partition ID. So basically you can add a new column called Partition ID, and that partition ID will be generated. Okay, Spark underscore Partition ID. How it will work is, let me show you with the 100 records so that you can able to understand very easily. Execute this. Okay. Now you check the number of partitions. Number of partitions it created is 8. But how this partition ID will look like? Let me show you. 100 records I want to display. Yeah, 100 records I want to display. See here. So all these are a 0th partitions. From here to here, 0th partition. That's why when I generated a Spark Partition ID function, when I have used under Partition ID column, so whatever records are there under a partition 0, everything is added here. You see, all these are basically belongs to a partition 0. Next, from here to here, these are belongs to partition 1. From here to here, this belongs to partition 2. From here to here, partition 3. Okay, from here to here, 4, 5, 6, 7. Okay, total 0 to 7 partitions you are able to see, meaning total 8 partition you are able to see. Now what you can do to get, if you have a lot of records, if you have millions of records you no need to worry much. What you can do, you generate a partition ID. Okay, from this partition ID, if you want to know just the number of partition, the other way what I'm saying is generate a partition ID, select the partition ID column, only this column you select. From there you say distinct. Basically you need a distinct partition IDs. Once you get a distinct partition IDs, you know, right, distinct means it will give unique values. If the 0 is repeated again and again, it will not give you. It will give you only the unique partition IDs. So these, once you get unique partition IDs, you can say count to get the number. Whatever number it is giving, this is the number of partitions it is created. You can able to understand very easily. Clear? There are two ways which you can use to get the number of partitions from the data frame. All of you clear now? So this you already understood. Okay, data frame. Now you also know the number of partitions it is created for the, I think this year I am using the I think 10 millions I am using, meaning 100 lakhs records are there. Okay, you can see 100 lakhs records, meaning 10 million records I generated, and I'm just trying to get the count, the number of partitions it has created. So 8 partitions only it created. Now I want to know the number of records are there in each partition. What you can do, take the same data, group by partition ID. Let's say I have a cricket players, Chennai team 11 members are there, Bangalore team 11 members are there, Hyderabad team 11 members are there. Now I will say group by team. So then what happens, all the people are mixed now as of now. Now I will say group by team. Then one group will be created for Chennai, one group will be created for Hyderabad, one group will be created for the Bangalore. Now I can just, once the groups are created, just Chennai people I will ask, tell me how much count. Bangalore people I will ask how much your count. So Hyderabad people I will ask how much your count. So that count I will display using this show. Now you see, these all things we have used in our sessions. Okay, see here, it will clearly showing these are the number of records from each partition. Very, very clearly you can see even distribution happened, proper even distribution happened when you create the data frame. Okay, so now using the repartition, I am trying to decrease the number of partition to 6. What happens? Okay, 6 I have done. Now I am just asking the count, the number of partitions now, how many are there? So 6 partitions only there. Now I am going to ask the records in each partition using this. So now you have, earlier we have 8 cricket teams. Now we have only 6 cricket teams because we have repartitioned to 6. Now you see even distribution, 1 or 2 records, that will not be a considerable number. So basically it's an even distribution. Now same like 10 million records I'm taking using the Coalesce, I'm decreasing it to 6. You see Coalesce of 6, I'm decreasing partition ID, Spark underscore partition ID. Now df1.select of partition ID distinct.count to check the number of partitions. Check the partitions now. So 6. And if you see the partition ID here, it will tell you, you can see here, this is the number. So what is the number you are observing here? 250, 250 here, and this is 125, this is 125, this is 125, this is 125. But there is an uneven distribution. You can clearly see even in the RDDs we have observed, even in the data frames we are observing the same issue. Okay, so here you have applied the Coalesce, okay, whereas here you have applied the repartition. Okay, so if you see Coalesce, how much time it took? 0.23 seconds, little bit less time. But in repartition there is a shuffling, that's why you can see little bit high time, little bit. Okay, basically there will be, if you have more than more records like this, more columns also, if you have, we have only few columns, right? That's why it is taking less time. But if you have more columns also there, then a lot of data it should shuffle, then basically repartition will take more time compared to the Coalesce. Compared to the Coalesce, repartition will take more time. Clear till here? Now we will talk about how to set Spark configuration for partition size in bytes. So basically now I want to know what is the default partition size. So some number it has given, this is the bytes. Okay, you take this number, you go to Google. Okay, now you can see here bytes to MB. You put your bytes here. It is saying by default the partition size is 134 MB, meaning if we have a 1 GB of file, 1 GB means how much MB? 1 GB means how much MB?
1024 MB.
1024, or some people will say 1000. Let's consider if it is a 1000. If it is say 1000, then if it is create 1000, let's imagine just 1 GB of data is there. So each partition is basically, it is creating approximately 134 MB. 134 into how much I need to add to get a 1000. I think it will be, let's, if you take an example of very easy example, if you have 134 means 260, 520, 4, 3, 7 partitions will come. Okay, basically what happens is, let's imagine very simple example I'll give you. Okay, you have a file with 260 MB. You have a file with a 260 MB. Now can you guess it and tell me how many partitions it will create? Very simple example. I have default partition file size is 134. It is taking, you can clearly see I just got the configuration. I have converted that bytes to the MBs, 134 MB. Now I have a 260 MB file. 260 MB file. Now how many partitions it will create? 260. 2 partitions only. 134 into 2, how much? 268. Meaning first partition will be a 134 MB data. Next partition we will be having only 126, because 126 plus 134 how much? 160. 126 plus 134 is 160. That's why these two will be basically, if you have a 260 MB file, then it creates only 2 partitions. Clear? Now let's say I'm setting the configuration something like this. I'm changing the default behavior like this. So what I'm doing, create a partition of 1 MB. If I have a 260 MB file, how many partitions it will create now? How many partitions it will create now? 260. Okay, let's see practically, is it true or not? Let's execute this. Let's see now, is it set or not? Yes, the default was overwritten. Now Cloud Pandit DS, basically I have a Cloud Pandit dataset folder. Under that I have kept some files. Okay, under that, so this is the only data file. These are dummy files, you know, right? When you write from the Spark. So this is the CSV file. It is of size this much. Okay, what is this size? This is the size. Let's see how much MB it is. It is basically 67 point something. meaning how many partitions it should create. For 1 MB, one partition means 67 MB, 67 partitions. 0.1 means for that one extra partition. Total, how many partitions it will create? I'm shouting like this, nobody is responding. How many partitions it will create? 68. Okay, let's see. So I'll just read that particular CSV file now. So I'm just pointing to the Cloud Pandit DS. Okay, I'm just trying to get the num partitions. Let's see now. Is it creating 68 or not? Yes. Okay, next. Let's say I'll set it same file I want to read, but this time the default behavior I'm setting it to the 2 MB instead of 1 MB. I set 2 MB. If you set 2 MB, okay, 2 MB, if you set, how many files it will create? How many partitions? 68 by 2, meaning 34.
34.
Clear? So 34. Let's see. Yes, 34 are getting created. Next, max partitions by is 5 MB. I'm setting this time. 5 MB means how many partitions it will create? 14 5 is 70. Okay, 13 5 is 65 only. So that's why 14 partitions it has to create. Let's see now. I just executed this, right? If not, let's execute once again. Now execute this. You can see it's a 14 partitions will be created here. Next, max partition bytes are 5 MB. Again, I'm setting 5 MB only. So this time there is another dataset 1. Here, if you see, there are 2 files I have. Okay, there are 2 files I have. I think don't consider. I will override this parameter. See, I am just setting it to a 1 MB. 1 MB again. Basically, if you want to see, you can see this is nothing but 1 MB. I'm setting again 1 MB. Got it? So if you see, this is basically a, I think I'm not very sure the numbers. Let's see here. 3.5. So this is basically 3.5, and I think this is a 1.7. So 3.5 and 1.7. So here 3.5 means each 1 MB 1 file, meaning 4 partitions are here. Here 2 partitions. Total, how many partitions it will create? When I read this, first set up this, then you read from the dataset 1. Okay, folder is dataset 1. Now this time it will read. It will basically create a 6 partitions. Clear? Let's say if I make it as a 2 MB, read it now. 3. Got it? Everybody understood? Any questions here? Srija, you have any questions? You are asking something. Srija, tell me your doubt.
Sir, actually in repartition progression, we in repartition also we can decrease user partition. Then
Yes.
why we have to use Coalesce?
Coalesce will have less shuffling, right? Data will not be moved, right? You did not understand. Repartition means, let me give you example. Okay. Coalesce, what it will do, repartition, what it will do. Let me explain here once again. Let's say Coalesce, how it will work is, let's say I have a one person with 1 2 3, another person with a 4 5 6, another person with a 7 8 9. Now Coalesce, how it will work is, if I make from these 3 partitions to 2, if I make, then first it will fix 2 partitions as it is, it will keep. Okay, 1 2 3 4 5 6, it kept as it is. It is not moving these records. So just the third partition data it is taking and it is adding maybe 7 8 9 like this. Okay, this is uneven distribution came now because this partition it has taken and added here. That's all. There is a repartition like Coalesce happened. Coalesce means decreasing the number of partition happened, but the problem here is uneven distribution. What happened? This is fixed. This is not moved anywhere. This is also not moved anywhere, but this is just moved to this first one and it is just added 7 8 9. Now from 3 partitions to 2 partitions we have done. Now let's say if we use the same instead of Coalesce here, Coalesce, if you use the repartition, what happens? How it will work? For same case, repartition, how it will work is 1 comma 2 comma 3, right? So we are not sure. Entire data will be merged and it may be something like this: 1 4, okay, 1 2 4 5 7, something like this. Then second one may be something like this: 3, then 5, sorry, 5 is already moved there, 6 and 8 9, like this. Got it? Meaning from here there is no fixed, entire data will move. So here entire data, some records are moving to here, from here some records are like only 2 partitions, right? 2 partition means basically this entire data is moved to some records to here, some records to here, and again 1 2 3, out of 1 2 3 some records are moved to here, out of 4 5 6 some records are moved to front and back, something like that. So everything will be moved here. But here if you see 1 2 3 4 5 6 are fixed, not moved here. Got it? But you see 1 2 3 is there? No. 3 is moved to second partition. Now similarly 4 5 6 is there in same place? No. 4 5 6 is not there, only 6 is there. 4 5 is moved to the first partition, meaning lot of data movements are going to happen in the repartition, whereas Coalesce, the data movements will be less. So when the data is moved less in the network, the performance will increase. That's why always recommended in interview, or if anybody asked you which one you will use to decrease the number of partitions, Coalesce. Why you will use Coalesce? The reason is it will have a less movement of the data, less shuffling of the data. It will improve the performance. But they may ask, is there any disadvantage with the Coalesce case? The disadvantage is, you see here there are 5 and 4. There are most probability of getting the even distribution is more in the repartition, whereas in Coalesce, if you see, what is happening is this uneven distribution possibilities more here, because like entire partition is adding to the one of the partition. So in that case uneven distribution possibility is more. Got it, Srija? Now understood? Still if you are not clear,
Yes.
let me know.
Clear, sir.
Okay, any other doubts? Okay, let me stop the recording. I'll discuss all other doubts. Okay, thank you.